sound on. Transition. I just realized I forgot to do the phone part of it. But hello everyone. How are y'all doing? Mama, how are you doing?
Okay. How are you doing?
Doing okay. Make sure my sound is off. Make sure I like the stream. And then pull up everything. You'd think I would have like this all set up ahead of time, especially because like I thought I was ready ahead of time, but nope, apparently not. Let's see. Do I have anything exciting to share from yesterday? I mean, not really, unless you want to talk about air conditioning stuff in the window. Not really important.
I mowed.
Mowing is an activity.
It was hot.
Yeah. It is not pleasant outside at the moment. Yeah. Other than that, I don't have anything to talk about before Sudoku, so are you ready for some Sudoku puzzles?
Yep.
Alright, so first puzzle we're going to do today is called the composite thread. This is our third attempt at this puzzle, and that's because we didn't read the instructions correctly. Now I'm going to read the instructions here. So this is the composite thread by Palpot. Normal Sudoku rules apply, i.e. place the digits 1 through 9 once each in every row, column, and 3x3 box. The 3x3 box borders divide each blue line into segments. The digits on each segment of the same line must sum to the same total. So if we look at this colorful line down here, the blue line here is split by the box borders, the 3x3 boxes. So this purple line is separated from this green segment, the blue segment, the yellow segment, and the red segment. That's what this line entirely is separated into, is each colored region. And so for the equal sum line, each of those regions is the same sum. So if I put 1 and 6 here, 2 and 5 here, 3 and 4 there, I could do 1, 2, 4, and 1 and 6 again. And everything would be equal to 7 as a possibility. The next part is that the digits along each line must sum to a unique number, and the sums of these lines must form a set of consecutive numbers. Now, the first time I read that rules, the second time I read those rules, the third time, the fourth time, the fifth time, sixth time, seventh time, I interpreted this line, the digits along each line must sum to a unique number, and the sums of these lines must form a set of consecutive numbers, to mean that the sum for each particular line being the segment. So like this one, we showed an example where it could have been 7. That is not what that rule means. And I'm not the only person to misinterpret the rule that way. They mean the digits along each entire line must sum to a unique number. So if I were to add up all of the digits along here, in the example where I had it being 7, that would be 7, 14, 21, 28, and then 35 would be the sum of the entire line. And then, if we look at the sums of the other lines, those two would be their entire lines. So like this one here could be 10. Well, add another 10 and another 10, and you get 30 for the top line. And then so you've got, say, 30, and you've got, say, 35, as a couple of examples. So that's what we need to do. The working out that we've done previously here, where we got each set to be within, or the What does that mean? How, like, this, we ruled out 7 on this line, we ruled out anything smaller than 9 on these pair of lines. All of that working out, completely useless. So, now that we have a better understanding of the rules, let's go ahead and give this a quick restart and operate under the correct rule set. So, if we know that this entire line must be consecutive with this entire line, this entire line, this entire line, and this entire line, then we have a different set of restrictions to consider. Now, I did look at the video on the Cracking the Cryptic channel that explained this, where they solved this puzzle, or Simon solved this puzzle, and he said something about thinking about the sums. And so if we look at the top line, line 1, it is 3x, whatever x being that particular line. Line 2 is split into 2 things, so let's call that 2x. Line 3, or line 2 is this smaller one here. Line 3 is going to be the longer one.
Maybe you should color the lines.
We could color the lines too. And we could do red, yellow, blue, green, and purple. Red, yellow, blue. Line those up on the right side there. Blue is split into 1, 2, 3, 4. Call this A, B, C. Actually, there we go. The green line is 5, and then the purple line is what, 3? 1, 2, 3?
Yeah.
And we know that those digits are in some consecutive order. Now, one other thing that you can think about with these is that they are all multiples. This is a multiple of 3, this is a multiple of 2, this is a multiple of 4, multiple of 5, multiple of 3. So none of those can be prime numbers. Now, one thing we know about the red line is that it's minimum 30. The yellow line would be minimum 18. The blue line would be minimum 27. Because while... Well, no, that's not true anymore. Never mind. The green line is minimum 7 times 5 is 35. And the purple line would be minimum 8 times 3 is 24. What would the blue line and the yellow line's minimums be? I guess it would be minimum 6, wouldn't it? Yeah, I believe so. No?
Well, like the yellow, the minimum on is 6 and 3 would be 9.
Yeah, but we know that the larger portion
Oh, right.
is equal to the smaller portion. And since that's mid 6,
yeah,
that
12.
would be another 6.
And 24, yeah.
Okay. So that means our minimum has to be 35. So, or the smallest value that the largest number in the consecutive set can be is 35, which would be 30 through 35. Now, slight problem is that 30, 31, 32, 33, 34, 35.
That's 6. Only 5 colors.
All right. I did mess up because I don't know how many are in 5. But you'd think I would get that one because 1 through 5 is 5 digits, but I included a 6 with the 0 because I'm a programmer and I start counting at 0. Excuse me. Anyway, this 31 here is prime, isn't it? It's not divisible by 2. It's not divisible by 3. It's not divisible by 5, and it's not divisible by 7. And I don't need to check. Well, I technically didn't need to check 7, because 7 squared is the first number that would be divisible by 7. That's composite. That wasn't divisible by another prime, which is 42. And I don't have to check anything larger because if a number is composite and it's a multiple of 11, like 33, 33 is already a multiple of 3, a smaller prime than 11. So 31 is prime, so we can skip 31. So then we move our window over to 36, and that brings all of our minimums up to 32.
Except for green.
Correct. Now, what we should consider is our maximums. And 24 times 3 is not possible for the red line. Because if I did try to do 24 or 23, I would have to do 7, 8, 9, and that would be 4 digits, or 4 squares with only 3 digits. And if I made the smallest of those one smaller and turned it into a 6 and make that 23, well, that's also not possible. I would have to go one smaller to 5, and then 6 and 7 to have a possibility of... that would be 22, because that's 13 and 9. So 22 times 3 is, 66. However, yellow is going to be 17 times 2, which is 34. Blue cannot be 17, it cannot be 16, it's going to be 15 times 4, which I believe is 60. Green can go all the way up to 13 as its largest value. 13 times 5 is going to be 65. And if we look at purple, purple is again not 24 or 23, so it's going to be 22 times 3, which is going to be 66. And now...
No, purple would have to be...
All right.
The max any segment is 17.
Right. My apologies. 17 times 3 is going to be 51, I believe. Yeah, because you get 30 plus 21. Okay. Now the smallest possible value in the largest possible set is 30. My apologies, viewers. 34, 35, 36, 37, and 38. So I can have these as my possible windows. Because I could not exclude 34, because then the yellow line could not have a possible option. Now, the other thing is that the yellow line must be 32 or 34, because it's a multiple of 2. So it only has those two options.
And the green line being a multiple of 5, it's going to have to be 35.
Right. It's the only multiple of 5 in that window. And that's from 7, correct?
Yes.
So these 3 are 7, 8, 9. 1, 2, 4. I'm not going to bother marking the rest of it. I'm just going to get rid of the rest of these. Now 33 can be red or purple. Oh, is 37 prime? So I only have to check 2, 3, 5, and I don't need to check 7 because that would start with 49. So it's not 2, so it's not even. 3 and 7 is 10, so it's not divisible by 3. And it doesn't end in a 5 or a 0, so it's not divisible by 5. So I believe 37 is prime, which means it cannot be a multiple of 3, cannot be a multiple of 5, cannot be a multiple of 4 because it's not a multiple of 2, and we already know it's not a multiple of 3. So 37 is not allowed as an option. So that immediately forces it to be this set of values. 4 can be 32 or 36. And then 33 can be, or 3 can be 33 or 36.
Right, and since there are 2 that are divisible by 3, they have to be 33 and 36.
Right.
So now yellow, we know, is 17.
Um, 32 divided by 4 is going to be 8. That is our blue line. Well, it has to be a 7 and a 1. That's 7.
Is going to be 7.
Know.
Yeah.
And so that is going to be
11 or 12.
For red and purple. Now, 1 and 2 is 3. And 8 is 11. So this could be 1, 2, or 3. Where this top one isn't 1. I'm going to add the conflict checker back on.
Well, and yeah. In the purple, the 3 cell with the 8 or 9, the box 7, has to have a 1 in it.
That's true. Two, 3, 4, 5. So these two have to sum to 7. So it can't be 2 or 4.
And box 1, since red sums to 11 or 12, either 1, 2, 3, 4. 1, 2, 3, 5 would be 11. And
And
1,
it
2,
can be 1,
3,
2, 3,
6.
6.
Yeah,
Or
it's
it can
1
be
through
1,
6.
2, 4, 5. 1's still
Right.
required. And so is 2. You have 17 here and 8 there. 17 and 18 is 25. Is that right? 7 and 8 is 15, and another 10 is 25. So the last 3 must be 20. Oh.
Oh, box 2. Red is 11 or 12, but yellow is 17.
Yeah. So
Blue
we've got
is
25 here. Is 8.
so 25,
Minus
36. So it's 36 or 37 left. So 8 or 9. Okay, that's not really that helpful for those two. All right, box 9, green is 7, blue is 8. That's 15.
and purple's 11 or 12.
Right. If it's 11, 15, and 11, God, why can't I add right now?
26, I believe.
26,
Which
which would
would
be
be,
24 left over.
yeah.
And if it's 12,
Wait, is it 24?
wait a
Because
minute.
20 would put it at 46. It should be 19 left over. Calculator.
Yeah,
45.
if it's 11,
Minus
there's
8
19.
minus 7. And then minus 11, 19. Minus 12 would be 18. Which has
Yeah,
lots
so
of
that's
possibilities.
right. Neither one of those was helpful. I was hoping there would be some helpfulness in one of those,
Yeah.
especially
Same.
box 9 with the 2 low.
Now, this cannot be 3, 5, because we know that these two sum to 7. And if this was 3, 5, I'd have 2 and 4 left over, which is only 6. 3 and 5 isn't allowed. 4 is never allowed. Not for 8. This one doesn't have the same restriction because it doesn't see both of these. (45) minus 17 minus 8 is 20. Minus 17, I mean, that just is 3. 3, 4, 5, 6, 7, 8. It can't be a 7. Now, where do we need to look? Well, this one right here is 11 or 12. Where do we look here? Oh, let's say this was not 3, 5. We'd have 1, 2, 6, and 7 lining up there. Would that be broken? I don't think so. So it would just remove a 2 from here.
Yeah.
Okay, we know 1 has to be one of these two, so 1 and 7. And 1, if 1 was paired with 5, then this would be a 3, but that would be 9. So 5 isn't allowed, and I think 3 isn't going to be allowed either. So this has to be 2 or 4. So now we get a 1, 2, 4 there. This isn't a 2, that's not a 6.
I'm going to jump over to purple.
Okay.
Okay, let's say purple is 11, because
Okay.
that gives us the most restriction in box 8 or 7. Because if it's 11, then it's 8 and 2 in box 8, in box 7.
All right.
Box 7. Thank you. I was just going to say scoop or script. That'll work. Because that pretty much sets everything up. Okay, then in box 9, 11 we can't use 2, 7. That would have to be 3 and 8. Because you can't use 2, 9, 5, 6, or 4, 7. Because the 2, 5 in green, yeah.
Yeah. So we need what? 9, 4, and 6? What would this be? 9, 1, 2.
Well, and
3 and
3,
4
4,
is
5
7.
is already 12.
Okay. So that's
So
not
it
possible
cannot
then.
be 11.
Oh, I should be doing it this way.
Yeah. That's why I said it'd probably be better to use superscript, but whatever.
So we know that this is 12 and this one's 11.
Right, which is 1, 2, 3, 5. Yeah.
2,
And the 2,
3,
3,
5.
5. Yeah.
Places 4. Places
And 4, 3.
3, 2, and 9, 8.
Well, that didn't help purple in box 9 at all, did it? It could still be 3, 9, or 4, 8.
Yeah.
6 is the only thing that's
here. 3, 4, 5 is still the minimum here. So
right.
7, 9, and 2.
All right. So it's 6, 7, 8, 9 left across row 8.
Three fives can take 5 out, so that's a 5. Three, 4, 6,
4,
8.
6, 8.
3, 4, 6, 7, 8, 9. 4, 7, 7. It cannot be both 3 and 4. But we know it has to be 4. Because if it was 3 and 4, because we know this is 17, it would be 3, 4, and 10. Well, that's not even possible. So this has to be 3. It cannot be 4. No, it could be 4, 6, and 7.
Well, that's what it has to be, because you have it's 4 and 13 is 17.
That's true. So we can't do 8 or 9. 6, 7 pair. Just going to place 1, 6. 6 and 2 are removed as possibilities there. That's not a 3.
Okay, the blue in box 2 can't be 3, 5, because it would make both the green and the purple 4.
So 1, 7, 2, 6, 7. This one's just 9, 2, 7, 6 here, not 6 there.
One, 5, 8, 9.
This one can't be a 1 because of the 1, 7.
Well, and under the yellow can't be 8 or 9. It's got to be 5.
That's true. One, 9, 8, and 3, I think. None of those is 1, 9, and 3. So that's just 3, 8, 9. So that's a 1, that's a 9. So 5 and 7, I think. 3, 5, places 7 and 5. 3, 7, 8. Can't be a 3 because of the 3, 5, which this one can't be a 3 as well. So this one's 3. 6, 8, 9. 6, 7, 8, 9, 4. 6, 7, 8, 9, 4. This is 11, 19, 36, 11 plus 17 plus 8, 36, minus 45 is going to leave us with a 9. So 1 and 8, 7 and 2. If it was 4 and 5, these would both be 3s. So this is a 3, 6 pair. One, 2, 3, 4, 5. I don't know what I'm doing. 11. That's minimum 3. That could be a 1. Apparently this one's minimum 6. So that's 10. So can't make that a 7. Can't make that a 2. So this one must be a 4. And 9. Seven, 8, 9. 8, 9, 7. Four is right there. I think that's a 5. I'm just going to fix these two. So I need a 2. I need a 3. I need a 7 and a 9. Here we go. Much easier when the rules are understood
fully.
Yeah. So, oh, I guess one of these days I will remember to put the puzzle in every time. There we go. So, row 3. Unfortunately, I don't want to say this puzzle is average as far as niceness goes. But I also don't want to say that it's like not nice, so I guess I have to go with regular nice. As far as difficulty, once we read the rules correctly, I guess it's kind of an average puzzle. Yeah.
I'm curious on the comments for this one.
So submit that one. So you've got Killer Rectangle, who made the same mistake that Wuck did, and Wuck made the same mistake that we did. Glum Hippo just said it had an idea that simply had to exist. Marty Sears, beautiful puzzle. This rule set really appealed to me, made me want to solve it. Skojo just said really cool take on the RSL Renban prompt. The meta Renban rule works so nicely. And other people.
Well, there are obviously multiple people that misread or misunderstood.
There are 2 people.
Yeah, but given the number of solvers, 67 times, and only a handful of comments.
Yeah. I do think I want to comment here. In case anyone struggles with the final rule, it is talking about the sum of the entire blue line just its
segment,
not just the segments
or region sum
split by the 3x3 boxes. So if the top line had a region sum of 20, then the entire line would sum
60.
Yeah, I'm trying to decide whether or not I want to say that it would sum to 60, but yeah, sum to 60, which would be used. So the top line would be 60 in the consecutive set for the meta Renban. Stared at this puzzle for 3 hours over 3 days. Before
I learned I was reading it wrong.
Yeah. Okay. First try. All right. Let me get rid of this for now. All right, and we will bring this one back if we get to the other puzzle that we are procrastinating on. I have nothing else to say about this puzzle. I have already saved it in my notes, so let us go to puzzle number 2 for today. Do you want to give this puzzle name a try?
No.
I
don't speak German, unfortunately.
Let's see. I should probably... Okay. So if I plug this into here, and I say pronounced, I give up. I tried. It was going to be too much effort. Okay. I'm going to pronounce it like the American that I am. Augen auf beim Rattenkopf. That is the closest that I can get by reading the letters as I understand them, which may not be how they're written in German. Since English is a Germanic language, right?
It has a lot of Germanic influence, yes.
Yeah. I mean, I guess one way I've heard English described is like 4 languages in a trench coat. But I guess I've also heard it described as like I don't know, a bit more rudely per se, in a way that's like that talks about how English steals so many words and stuff. So, to continue here, this puzzle is by Olima. Normal Sudoku rules apply. Dutch/German whispers. Adjacent digits on an orange/green lines differ by at least 4/5. I would have just put these on 2 different lines. The Dutch whisper lines are orange and differ by 4 at least, and the German whisper lines are green and differ by 5. Excuse me. Renban, purple lines contain a set of distinct and consecutive digits in any order. Thermos, digits increase on a thermo from the bulb. Parity, adjacent digits on a red line differ in parity, their evenness or oddness. Kropki pairs, black dots indicate digits in a 1:2 ratio, and white dots are consecutive digits. Not all dots are necessarily shown. Alright, so. Restart just so we have accurate time. Yeah. So if we look at the ones in the corner, they have to be 1, 2, 4, 8. Because that's the only chain that works. The only other digits that work on a black Kropki dot are 3 and 6. So the entire set would be by all of these 1, 2, 2, 4, 4, 8, or 3 and 6. you cannot use 5, 7, or 9 because they're odd. You can't divide them in 2. And because they are greater than 5, or in the instance of 5, equal to 5. And when you double them, they become 2-digit numbers, so you can't use them. 6 and 8 being larger than 5, you can't double them, but because they're even, you can divide them by 2 and get 3 or 4. Now, the other thing to think about here is that I need 5 digits in order. So if I did 4 and 8, 2, 4, and 8, I don't think it would be possible, because 2 and 4 are already necessary up here, so I can't use 1, 2, 3, or 4. So this is going to have to be 5, 6, 7, 8, 9, which is going to be 7 in the middle. So 5, 7, 9, remove from there. 6, 7, 8, remove from there. This is going to have to be 3, and 8 is going to be removed. 2 and 1, 4. And again, I need conflict checker on. Excuse me. Now the middle digit down here is going to have to be a 4. So 2 and 8. The reason it has to be 4 is because it had to be either 2 or 4. If I tried to put 1 or 8 in the middle, then the other 2 would be the same, which is not allowed. So that's going to give us 1 and 4 up here. Okay. Now, these two are consecutive. Well, that doesn't mean a whole lot. 2, 3, 4, 5, 6, 7. So these can't be 7 or 4. These two can't be 4. I need a 4 somewhere. 7 is not required. So it's 1 or 7, which is going to be on here. But I am going to have to use 3, 5, and 6. Well, this one is not going to be 1 because of the thermo rule. So that's not a 1. But nothing else is going to be removed from that. So now I ask myself about the German whisper line. One of these two is going to have to be 6 or 8. Which means the other cannot be a 4. Which means it's going to have to be, 6 and 1. And if one of them has to be a high digit, then it's going to have to be... Oh, hold on. It does have to be 6 or 8. But I messed up and was thinking that they had to be... the 8 and the 4 were connected to each other, but that wouldn't make any sense because the 1 and the 6 wouldn't connect together. But 4 is going to be removed because 4 would be paired with 9, which is not possible on the other one. So the other side can't be 8. Okay. So now, this, if it's a low digit, has to be 2 or 4, because of the 1, 3 over here. That's going to eliminate 6 as a possibility.
Well, 4 can only go to 9.
That's true.
On a German whisper.
So
and
4 would not be allowed. So then if it's a high digit, it has to be 7, 8, or 9, but that's less restrictive. So that's going to give us 1, 2, 3, or 4, and then 8 or 9. This one can be any of the high digits, and it can be any of the low digits. So that's not useful at all.
What was the red line?
Parity.
Parity,
Adjacent
that's right.
digits on red line
Yeah,
different
even or
parity.
odd.
One thing we know is that 8, 9 is taken up in row 3, because if this is a 2, then these would have to be 7, 8, or 9. Well, 7's already taken up, and since they can't be 6, then they're going to have to be 8 and 9. So this one's the 8, this one would be the 9. And so this is either 5, 6, or 8, 9. And since one of those options is 8, 9, the other, well, I guess this could be 5, 6, and this be not 8, 9 over here, so never mind on that one. So now we got to consider this one. So these two we know are different in their high lowness. So if I made this one red, this one would be blue. I could make that one blue and that one red, and this one red and that one blue and that one red. If I put a 5 somewhere, we know those have to be that way. I think this proves that we can't have a 5 on here. Because if I put a 5, like let's say this one was a 5, it would have to be surrounded by 1 and 9. Because those are the only only digits that are 4 away from 5 or more. But they can't be more than 4 away from 5 because 1 and 9 are the farthest they can be away. But we know that if this one's red, then this one would be blue. So that would be the 1, and that would be 9, but then those would both be red. So that can't be a 5. And if I make this one 5, this would be 1, so this would be 9, but then this would also have to be a high digit, which you can't make a high digit 4 away from 9. So that can't be 5, and the logic is true on the opposite side as well. So 5 has to be one of these two digits, which lines up with the 5 as one of those two, so we get 5s across there. Now, since we know that these 3 are all the same high-lowness, they cannot be low because of the 3, 1 over here. So these are all high digits, these 4 are all low digits, so this is not an 8, this one is not a 9, and that means this is a high digit, and this one's a low digit, which means this is 6 or 8, and then this is 3 or 4. Excuse me, this is a high digit, 6, 7, 8, 9. I think these have to be 7, 8, 9, so this is going to be a 5, 6 pair here. Because if any of these were 6... Oh, wait, these are on Dutch Whisper lines. So 6 can be surrounded by 1 and 2 as possibilities.
Row 2 has a 6, 7, 8, 9 quad. 2, 4, 5. The box 2, the cropkey dot, the 2 and the 4 come out. Box 4, the 8 is a crappy dot.
9, 8, 7, 6, 5, 4. So this one's 4. That can't be 5. Those aren't 4, so those aren't 8. 1, 2, 3. This can no longer be 5, 6 over here. We'll break the 5, 6 here. So 9, 8, 6, and 5. 7, 8, 6, and 5. 7 and 6. Not a 6. This can't be 3. 1, 2, 3, and 5. So that's 1, 2, 3, so that's 5. So this can't be a 3. 1, 3 pair makes a 6, makes a 3. If this is odd, this one's odd, this one's odd. And this one is even. 1, 2, 3 means it's not a 2. And this is also 4, 8. That's an 8. That's a 4. So 5, 5, 6, 1, 3, 5, 7. This one's a 6. That's a 2. That's a 5. That's a 4. What am I missing across the top? 7, 8, 9, I think. I don't see 6 or 3. 5, 7, 9, and 6. So this one's 9. The others aren't. These two aren't 6. So that is 1, 2, and 8. Let's go with these 3 because they have to be
4 and 6, or 2, 4, and 8.
2, 8, 4, 7 or 9. 2, 1, 3, 2, 6, 3, 1, 3. 5, 7, 9, and 2
1.
is
1, yeah.
3, 5, 7, and
6. 6, yeah.
these two aren't 6. So that is 7, 5, 3, 9, 1, 5, 7. 1, 3. So I can get rid of the coloring. These two are 1
and 3.
So 1 and 3 in that order.
5, 7.
5, 7, 8, and 9, I think. 9 pair places a 1, a 2, an 8, a 9, an 8, a 7, a 9, an 8. This is a 6. No, there's a 6 right there. It is 2. 7, 9. 5 and 8. No.
9.
5, 7, 9. I still need a 1, and I still need a 7. Here we go. Pretty quick puzzle. The logic up here with the Dutch whisper lines and the German whisper lines, especially with the way the puzzle rules were laid out, were a bit tricky. You have to think about whether or not a 5 can go on there. But other than that, it was a pretty straightforward puzzle. If I can highlight the right things.
You missed the first,
First letter.
Mm-hmm.
I'll get that fixed real quick. And then let's see if it's on Object Masters Germany.
Or paper puzzles.
Say, oh yeah. Keep your eyes open when buying a rat. Is what Google translated that into. So I don't see. Okay. I give up. I don't see it on Logic Masters Germany. But if somebody else does, please let me know. So with that being said, let us take on this next puzzle. If I can avoid coughing through it as much as I can. Alright, puzzle number 3 for today. Slightly Intoxicated by Eric Vader. Normal Sudoku rules apply. In this puzzle, 4 or 5 of the boxes have become intoxicated. You must determine which boxes are intoxicated. Cages within those intoxicated boxes all use drunken math and are summed by their digits' values. Digits 1 through 3 values are equal to 0. 4 through 6 values equal 5, and 7 through 9 equal 10. The intoxicated boxes are all orthogonally connected, and the remaining boxes are all not intoxicated, and the cages within their digits sum to the cage total. Okay. Well, this is either 1 or 3. Because 7's already equal to 10 if that is intoxicated. Alright, we've got 30, 45, so those could be correct. Aha! This one has to be wrong. So, 5 and 15 is 20, plus another 20 is 40, plus 4 is 44. So somewhere, one of these is intoxicated. This would be 2, 3.
Well, if that is 2, 3, then the 10 in row 9, the 10 box, is going to have to be drunk.
Okay.
Because, all the low digits are now used.
Yeah.
If that is 2, 3, and the 5.
Now we know one of these is intoxicated over here. So this 10 cannot be, because all of the intoxicated...
and the right side ones and the left side ones are not connected.
Yeah. So these ones And so that means this one has to be. So
1 from 2, 3.
Yeah.
0.
And then 5 or 6.
And that would
2,
be
8 or 3,
the other.
7.
Yeah.
6, 7, 8, 9. Now, it's 4 or 5 of them. So how far can I go? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So none of these can be.
Well, then that 60 or that 30 cage is 6, 7, 8, 9. Box 3.
Box 3. There we go. 6, 8, 9.
But how do you have a 30 cage that's only 3 digits?
Well, then that one must be intoxicated. Cages within those... Excuse me, in this puzzle, 4 or 5 boxes have become intoxicated. You must determine which boxes are intoxicated. Cages within those intoxicated boxes all use drunken math and are summed by their digit values. The intoxicated boxes are all orthogonally connected. Okay. I have, once again, fumbled the rules.
Well, we know box 2 is intoxicated.
Yeah.
Because you cannot do 30 in.
So we know both of these two are. Now, both of these could be intoxicated. We don't know that. Okay, if this 15 was intoxicated, then it would have to use the digits 4, 5, and 6, because 7, 8, and 9 are used up in the 30 at the top of the row,
Right.
or column. However, if that... well, it would make it so that box 5 couldn't be intoxicated. I was about to say it couldn't work at all, but those could just be 1, 4, 2, 3. Well, it would have to be 2, 3.
15 would have to be 4, 5, 6.
Yeah. So, okay. If... no, I was going to say if box 6 was intoxicated, the 10's done. So this would be 1 or 3. It's 1 or 3 anyway. But 5 here cannot be in the 15, so it must be in the 20. And if this box is intoxicated, then it would be... Oh, Torak is here. You were right, on the right track with the 15 cage in box 8. Now consider if it's not intoxicated. How are you doing today, Torak? Well, we know there's a 5 in this 20 regardless. I don't want to forget that it's a 20, so... I guess if it wasn't intoxicated, this has to be 4, 5, 6 anyway. Because we have to have a 5 in here. And then to make 10, I can't use 6, 7, 8, or excuse me, I have to use 6. I can't use 7, 8, or 9. The 4 is required down here to go along with it. So this is 4, 5, 6 regardless. Which means this has to be 2, 3. Because it cannot be... It can't be 1, 4. And so this box cannot be drunk. Or intoxicated, rather. It doesn't matter whether this one is. Although if it was... 1, 2, 3, 4, 5. It would have to be these 5.
And they're orthogonal, so box 2 has to reach box 9.
Right.
And it cannot go all the way around the left.
Yeah. So if it was this one, and that one, 1, 2, 3, 4, and 5, so it has to be these. So 4, 5, 6, 8, or 9. This would be 4, 6, 8, 9.
And 3.
Except I can put 3. Oh yeah, it'd have to be 3.
With 2 high digits.
Well, it can't be 3, 8, 9 up here, because 5 has to be up here. So it has to be 5
right.
with 4 or 6. Now, there's a bit too much going on. So this has a 3, and this has a 5.
Right. Box 4 cannot be drunk. Or intoxicated, excuse me.
Either can box 7.
Well, and box 4, the 15 cage, has to have the 5 in it. So it's going to be 4, 5, 6 again.
Does it have to have? Oh, yeah. It's similar logic to this one, but it's the 1, 2, 3 that forces the 4, which is then going to force the 6 to be added on. So 8 and 9 here. 4, 6, and 7, I think, are what's left over.
And the 2 10 boxes in cages in box 4. The bottom one can't use 1, 3, or 4, so it has to be 2 and 8. But we don't know whether it's 3, 7, or 1, 9 on top. Oh, well, yeah, 3 and 1 both have to be on the top.
One, 3, 7, and 9. Well, this one can't be 9, so it's going to have to be 7. Because the 8 and the 5 is 15, so I need 4, 6, 5, 8 up here. And now this is 4 or 6, along with 3 and 9. This one's number 4. So that's why 7. No. Because of the 9, got forced up here, along with the 1 and the 3. then that left 7 down there. There we go. One of these days my brain will work. Well, it is possible to get 30 with only 2 of the high digits. And 2 5s. But this one is going to have a 5. So that's going to be 1, 2, 3, 4, 5, 6. So I could do 7, 8, 9, and a 1, 2, or 3. But I could also do 4, 5, 6 with another 4, 5, 6 with 2, 7, 8, 9s. Okay, well, we know this one is 2, 8, or 3, 7. And then this one is 2, 3, and 5, 6. So the 5, 6 combines with that 5, 6, and the 2, 3 combines with the 2, 3 in the other space. 2, 3, 5, 6, 1, and 4. This one's not a 7.
Column 6 has a 4, 5, 6 triple.
Oh, that places a 7 then. 2, 3, 8, 9.
All right, box 8.
Box 8.
The cages there are 20 and 15, which is
For
35,
35.
which would mean the last 3 would have to sum to 10.
Uh-huh.
Well, you don't have any there. The top 2 cannot sum to 9. So that has to be drunk. Or intoxicated. Drunk, math, whatever.
So that's going to be box 1. Is going to look like this then. Well, this is going to have to be 7, 8, 9 with a 2, 3.
And that's a 7, 8, 9 triple with box 5. One has to be... Oh, well...
An 8 pairs with a 7, which would be 1, 6. And a 9 pairs with 6, which is going to have to be 2, 4. But I couldn't use 2, 4, because that would break this. Those would both be 1s. So this is 7 and 8. Um, 2, 4, and 9. Five, 6 pairs, what makes that a 2? Well, these two cannot be 7, 8, or 9. So these two have to be 7, 8, 9. And these have to be 4, 5, or 6. 7, 8, 9. Triple. Okay. 4, 5, 6, and 3.
Row 2 has a 5, 6 pair.
Place 2. 4, 6, 4, 3s, 2s, not a 4. 5 and 6 make 10. That's a 5.
Right, so the 15 cage is
a 10.
5 and a 10
and a 5.
and a 0.
So then this is 2 10s and a 0. So those are my 2 10s and my 0. Less helpful. 4, 5, 6, so 1, 2, 7, 8, 9. So that's not 1, 2. So then those are.
Right, look where 1 is a column. Never mind, it doesn't matter now.
Eight, 9 pair. 9, 6, 9, 3. 9s are out. 8, 9, 5. 6, 4, 5, 6, 4, 5, 8. I don't know what that one is yet. It is a 5, but I didn't know that when I clicked it. There we go. Excuse me. Alright, slightly intoxicated. Which I didn't put in the chat again. There. No one will notice if I put it in late, right? Logic Masters Germany. Vader. Right. Okay. We have one more short puzzle queued up, so let's go ahead and tackle that, and that'll probably be it for today. So, last puzzle for today, 3 is a magic number by KWOG. Normal Sudoku rules apply. The grid is completely covered with a thick, penetrating fog. Placing digits correctly will clear the fog and your anxiety. No guesswork is required. Box 3 is a magic square. All the rows, columns, and diagonals within the box sum to the same total. Crop key, a white dot separates 2 consecutive digits. A black dot separates 2 digits in a 1:2 ratio. Arrows, digits along an arrow sum to the total in the circle. And magic number 3. For the digit 3 alone, there is an anti-knight's move constraint and a negative constraint on crop key dots. This means that a 3 cannot be within a knight's move of another 3, or next to 2, 4, or 6 without a crop key dot chaperoning them. Alright. Then, well, if we know that box 3 up here is a magic square, first things... yeah. So first things first, how do we know that 5 has to be in the center? Well, a magic square means that all 3 rows, all 3 columns, and the 2 diagonals have the same total. If the 3 rows have the same total, and they therefore sum to the whole box, the digits 1 through 9, if you add them all up together, give you 45.
Link.
Divide that. Hump.
Link.
Blink.
Link.
Link. Link. Oh. No, I want to talk about the puzzle.
Okay.
You're not allowed to have the link to the puzzle in the chat. There. No one can do this puzzle except for me. Where was I? Oh, magic square. So the 3 rows, 1, 2, 3. We know that those 3 things add up to the same thing. The whole box is covered by the 3 rows, and the 3 rows are all the same thing. The whole box adds to 45. Divide the 45 by 3. That gives you 15. So we know that the 3 rows make 15, and the 2 diagonals make 15, and the columns make 15. So what does that tell us about the middle digit? Well, it's part of 1, 2, 3, 4 different 15s. And the only thing that has 4 different options around it is a 5 surrounded by a 10. Now, the other thing to think about is the number 9. If I place a 9 in this grid, let's say I place it here in this corner, then it would be next to 5 and 1, and 2 and 4. But then the other side, well, I can't place a pair of 3s for the 6 left over to make 15. So that means that 9 and 1 have to be on opposite sides this way. Well, the 9 is going to have 2 and 4 around it, and on the opposite side of the 2 and 4 is going to be 8 and 6. So then 3 and 7 pair with my 7 and 9. Now this black crop key dot over here is going to remove 7 and 9, which is going to remove 1 and 3 from over here. And if these are consecutive, then I cannot use a 6 or an 8. If these are consecutive, I cannot use 2 or 4. And now, if this is a 2 or 4...
You can't have the crop key dot on the right. That whole little column sums to 15. Well,
right.
9
so
doesn't work.
6, 8.
9's not going to work. And 7 and 8 is already 15.
Six, 13 and 2 more. There we go. Now, what about this 3? Well, we know that the magic number 3, for the digit 3 alone, there is an anti-knight's move constraint and a negative constraint on crop key dots. This means that the 3 cannot be within a knight's move of another 3 or next to a 2, 4, or 6 without a crop key dot chaperoning them. So where can I place 3 in box 2? Well, by Sudoku, I can't do those. By anti-knight, I can't do those 2. And because of the negative constraint for the crop key dot, it can't be those. Now, this is a black crop key dot, so this cannot be a 3, because if it was, that would be a 6, which would break that, so this is 3. Which is going to force those to be a 1-2 pair. One would make that 2, so that can't be a 2.
Oh, right, yeah.
Well, now this can't be... This has to be 2-4, because it can't be 1-8 or 3-6. This cannot be 1-2-4, So this is 3 and 6. 5, 7, 8, 9. And Black Crocky Dot cannot have 5, 7, or 9, so that's an 8.
And the other side of an 8 is
4.
always a 4.
This is 2 or 8. It could be 8 again. This is 2. This is 4. This was 8 again. Okay. Well, this arrow extends all the way down to here, so this cannot be a 5, because that's minimum 3. That's minimum 3, so now I'm at 6. This is minimum 3, so now I'm at 9. So, actually, I already have 9. So, a pair of 3s, and a 1-2 pair, 1 and 2. 6 here, these two aren't 9.
Three
Well,
can be
where's
placed.
inbox?
1.
So not there, not there. Anti-Knight.
Row 2 has a 3.
And 2 or 4. Threes. Anti-Knight, 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 so those are going to see that one. And Anti-Knight's going to block both of these. So that sees that, so that's there, that's a 6. This is both 2 and 4. Well, if I have to have 3 on here, it's going to be surrounded by 2 or 4, so that's 3, 4. This can't be the 4, because 2 and 8 is already there, so that's a 3. I was about to say that's a 6. This is 4. That one's 6. This is 3. That's not. Excuse me. Alright, what's left over in here? 5, 7, 9. What's left over in here? 2, 3, 4, 6 is all removed. 8 is gone. 7, 1, 5, and 9 places a 7. 1, 5, 9 triple places an 8. 1, 5, 9, and 2. Well, that's the 2. This can't be 1, it would be paired with a 2. 9 would be paired with 8, and 5 would be 4 or 6. Well, apparently this isn't a 5, it's a 9 and an 8. 5, 7, and 1.
1.
5, 7, and 6. 5, 7, and
1.
5, 7, 8, 9. Apparently that one's the 9. 5, 7 pair makes that an 8. 5, 7 makes that a 9. That's not a 9. 2, 4, and 8. 4, 2, 8. 5, 7, 9.
9.
1.
1. 6.
5, 7, 9.
Oh, yeah.
Do. 5, 6, 7, 9. Okay, well, 1, 2, 4, 8. 4 and 8 isn't allowed. And it can't be 3, 6, so it has to be 1, 2. 5, 6, 7, and 9. 5, 6, 7, 8, 9. 6 isn't allowed, 9 isn't allowed, 8 and 4.
Column 8 needs 2, 4, and 8.
2, 4, 8. 8, 4, 2. 4 and 8. 5, 7 pair makes 8, 4, 1. 5, 7 pair. 6, 9. This is what, a 9? No. 1. There we go. First try.
The tip of
5.
the arrow is the 7. Yeah.
5, 7, 5, 7, 5, not 5. 7, 5, 7, 5, 7, 5, 6, 7, 9, 5, 9, 6.
9, 6.
9, 6. There we go. That was a really easy puzzle.
That's really quick.
No. The text box that is in this here is really difficult to use, so it's kind of annoying. Another puzzle that's not on Logic Masters Germany that I can find. All right. With that being said, I have been coughing a lot more today than I have been previously. So I'm going to call it here. And we're going to leave this one till next week again. So this one was pretty hard. So with that being said, swap over to the full talking screen. Thank you so much for watching. Make sure to like, comment, subscribe, all that fancy YouTube engagement stuff. If you're interested in more content on this channel, that is Sudoku Mondays and Tuesdays at 8 p.m. Eastern Time. If you're interested in more gaming content, I play Monster Hunter World on Saturdays at 7 a.m. Eastern Time. And I promise I will play Final Fantasy VI so that way I can get to The Last of Us and Final Fantasy VII Remake. Aside from that, if you have any recommendations, put them in the comment section down below. You can access my Steam library in the description. And there's a donation link if there's a game that I don't have already that you're interested in seeing me play. With that, I have nothing else to say, so make sure to have a wonderful day. Again, thank you so much for watching.